Now that you get to know ADD and ADDI assembly instruction together, it's time to practice debugging and this assembly instruction. And this program is traced to a debugging program in simulator mode. And this window is about assembly instruction. And this window contains the set of the general purpose register. So it is necessary to look at each window simultaneously. As you can see, there are the 1 and 2, 3, 4 assembly instruction about add and ADDI assembly instruction. So before learning this assembly instruction, let's understand the syntax of this assembly instruction together. As for this assembly instruction, add value of the A5 register will be added to the S5 register. Result will be saved in the A5 register, and because A5 is the destination register for this assembly instruction. Before running this instruction, it is important to check the value of the A5 and S5 register. And at this moment, this window tells you about this information. This S5 register has the 1 and the A5 register has 0. We can expect the result of this instruction is that the A5 register will be updated to the 1 because A5 register has the 1. Okay, let's execute this assembly instruction 1, 2, 3 and by clicking step icon. So please take a look at this. The A5 register is updated to 1. So now it's about to run the second assembly instruction, and that is about this assembly instruction. So let me paste this assembly instruction. And this assembly instruction can be represented like this. The value of the S4 will be added to the value of the S6 register. What we have to do is to check the first source register, that is S4. It has 1. Oh, sorry, it has 2. And as for the second operand, this is the S6 register. It has 0x22. So after we run this assembly instruction, that we can expect that result will be this one, because this value will be added to this value, because add assembly instruction and support addition operation. So when running this assembly instruction, and please pay attention to the value of the A5 register, because as for this instruction, the destination register is A5 register. We will run this instruction 1, 2, 3. And please take a look at this. A5 register is updated to 24. The next instruction you are going to debug is the ADDI assembly instruction. Then please take a look at this. Then we will copy this assembly instruction. And this assembly instruction is considered the I-type assembly instruction because this instruction ends with the I character. So if I represent this instruction in another way, I can make this kind of equation. You know that the second operand is immediate constant. So in order to debug this assembly instruction, we have to check the value of the S8 register. And S8 register has this value 100. 100. So after running this assembly instruction, we can expect that result will be this value. As I explained it in the add assembly instruction, the destination register in this assembly instruction is A0 register. It is necessary to check the value of the A0 register. So I'm going to run this instruction. So please take a look at this. The A0 register is updated to this value as we expected. Now let's perform the last ADDI assembly instruction. In this case, S7 register is first operand, and this value will be added to 0x10. So we can expect that result will be 510. So let me run this instruction and please take a look at this. So S7 register is updated to the 510. So in this video, we practice add assembly instruction along with ADDI assembly instruction. As you can see, both instructions support addition operation. The only difference is the second operand. Add instruction, and it has the second operand as the register. But as for ADDI instruction, the second operand is immediate constants.